In this video, we're going to cover 4 example problems that all deal with synthetic division. Now, what is synthetic division? Well, it's the same thing as regular division. For example, here we have 15 divided by 6, that equals 2 with a remainder of 3, right? Well, in synthetic division, we're normally going to have a big, long polynomial here. That's still the dividend. There's going to be a divisor, which oftentimes is a binomial, but it has to have a degree of 1. Okay, it can't be a degree of 2 or 3 or 4 to work with synthetic division. So we're going to still have a divisor here, and then our answer is going to be a quotient, just like here 2 is our quotient, and we'll have a remainder of 0, 1, 2, 3, or any other number. Now, to be honest, the process of doing synthetic division is a little crazy. So you're going to start off by taking the coefficients along with the constant of your dividend, and you write them from left to right. So 2, 6, negative 29, positive 32, and negative 60. And then I look at my divisor, and if it's a binomial, I'm going to set that equal to 0. I'm going to solve it for x. So I got to subtract 6 from both sides. That means I'm left with x equaling negative 6. Now, that x value is going to what I'm going to put up here in the top left-hand corner, and I'm going to draw a long line like this, and I could start the whole process. So the first thing that I'm going to do is take this 2 and I drop it down to the front here, and I have to start with multiplication. I take this number here, negative 6, I multiply it by 2, that gives me negative 12, and I put that answer right here. And then I add these two numbers together, so 6 plus a negative 12 is a negative 6, and then I bring it back to this negative 6. Negative 6 times negative 6 is a positive 36. I add these two numbers together, I get a positive 7, and I bring it back to the negative 6. Negative 6 times a 7 is a negative 42. I add these together, I have a negative 10, and I bring it back to the negative 6. Negative 6 times negative 10 is a positive 60. I add these two together, I get 0, and I could kind of box it off here. This number here is going to be my remainder. Now, that's all this problem was looking for. It was looking for the remainder, and we have it. It's 0. But to compare it to division, I want to show what my quotient is, and these numbers represent my quotient. Well, let's see how we would write it. Our quotient is still going to be a polynomial, but if you see right here, the column that was dealing with our constant from our original polynomial, now the column that had the constant from the original polynomial was this one right here, but now down here that's being taken up by our remainder. So the constant of our quotient isn't going to be this number, it's going to be negative 10. So the constant of our quotient is negative 10. That means that 7 ends up being the coefficient of our x term. And then negative 6 ends up being our coefficient of our x squared term. And then 2 becomes our coefficient of our cubed term. Alright, so we have 2x cubed minus 6x squared plus 7x minus 10, and it has a remainder of 0. So, that's going to be our quotient. You could go backwards like that, or you could be like, alright, well, our degree is going to be 4 here, alright, and our quotient is always going to be 1 less degree. So you could have just started with this number here and said, alright, well, if we have x to the 4th, my quotient is going to start with x to the 3rd. So then you'd write 2x cubed minus 6x squared plus 7x minus 10. And then the remainder will go at the end, but because the remainder is 0, you don't have to write it. Now the second example is asking us to use synthetic division to figure out if this is a 0 or not. And if you look back at my first problem here, our negative 6 is our 0. So in my second one, I'm going to put my 0 of negative 2 up here in the top left-hand corner to start right away. And I take all my coefficients and my constant, and I write them from left to right up top. And I draw my line, I drop down my 1 here, and that starts the whole process. So negative 2 times 1 is negative 2. I add these together, I get 3, and I bring it back. Negative 2 times 3 is negative 6. Add these two together, I get 7, and I bring it back. Negative 2 times 7 is a negative 14. I add these two together, and I get a negative 2. That's going to be my remainder. So, is x equals negative 2 a 0? No, it's not, because for this number to be a 0, we have to get a remainder of 0 here. If this is not a remainder of 0, it means that this is not a 0. And if you're asking why, well, remember, the factor that creates this 0 is x plus 2. So if we're dividing this factor into this polynomial, it has to divide evenly to give us a remainder of 0. So if it doesn't divide evenly, then it's not going to be a 0, which means, or I'm sorry, it's not going to be a factor, which means it's not going to be a 0. And just for practice, I'll write my quotient. So my degree of the dividend was 3. That means the degree of my quotient is going to start with 2. So that's going to be an x squared. This 1 would go in front, but you don't have to write it if you don't want to. It'd be invisible. And then we have plus 3x, and then my 7 is the constant. My remainder now is a negative 2. So I'm going to add in negative 2, divide it by the factor that my 0 came from. So that would be x plus 2. And that's how you would write a quotient with a remainder other than 0. So we're adding that negative up top and everything. So if you want to write it a little differently, you could. That would be x squared plus 3x plus 7. And if it's negative, you could do minus that remainder of 2 over the divisor, which was x plus 2. That's another way of doing it, but either way works. Moving on to this one, we want to figure out if a minus 7 is a factor. So we're going to figure out what that 0 would be for this. So we'd take a minus 7, set it equal to 0, add 7 to both sides, that goes away. So the 0 that we'd be working with is 7. So that number is going to go up here in the top left. And then I take my coefficients and my constant, and I want to set up all my numbers. So I would start off by doing 10. That's with the cube term, a to the third. And then negative 70, that's a to the second power. But as you can see, I have no a to the first power. So when I'm missing a term like that, I have to plug in a 0 to take its place. And then I finish with my constant. And if you're saying, like, wait, why do I have to plug in a 0? Well, think, if that a was there, the 0 is a coefficient, would be 0 times a. So if you have 0 times any number, that's just equal to 0, right? So they're thinking, well, why would I even write that term right here if it's just going to be 0? So that's why we've got to take its place with a 0. Now I'm going to draw my line. I drop down my 10, and I start the whole process. So 7 times 10 is going to be 70. Add these together, I get 0. 7 times 0 is 0. Add these together, I get 0. And then 7 times 0 is 0. Add these two together, and I get 3. So that's going to be my remainder. Now 0 is going to be my constant. That would be c. This is going to be the term that matches up with just my a, and then this is going to be the term that goes with my a squared. So I'm going to have 10a squared plus 0a plus 0 plus a remainder of 3 over that factor, which was a minus 7. Now if you're thinking, like, wait, why do I have to write all my zeros? Well, you don't. You could just say that this is going to be 0 and then this is 0, so you don't have to write those. You could just do 10a squared plus that part with our remainder, which is 3 over a minus 7. So that quotient is going to be a little bit shorter. And then can we say this is a factor? Well, no, because the remainder is 3. It would have had to been 0 for a minus 7 to be a factor. And lastly, example 4 says we need to use the synthetic division to figure out the remainder. So I take my divisor, which is n plus 4, I set it equal to 0, and I solve for n. That means n is going to be equal to -4, and that's what I'm going to use up here in the top left hand corner. And then I take my coefficients of everything, so this is going to be 1, 10, 14, -40 is my linear coefficient, but there's no constant. And just like I'll go back to this problem right here. Just like we had to take the place of our a term, we're going to have to use 0 to take the place of our constant. So I put a 0 here at the end. And it's really easy to forget that, so make sure you look out for that. I drop down my 1 to start my whole process, so again I'm going to go quick. -4 times 1 is -4. Add these together, I get 6. -4 times 6 is -24. Add these together, I get a -10. -4 times -10 is a +40. Add these together, I get 0. -4 times 0 is 0. Add these together, I get 0. So the remainder is 0. And that's all we really had to do to answer this question, so look for the remainder. So just for some extra practice, I'll go ahead and write the quotient. So this now is our constant. This is going to be our n term, this is going to be our n squared, and this is going to be our n cubed. Or you could say that our polynomial up here has a degree of 4, so then I start with a degree of 3. So this is going to be 1n cubed, and then plus 6n squared minus 10n. Our constant was just 0, so we don't have to write that, and our remainder is 0, so we don't have to write in that remainder, so that would be our quotient, if that's what we were looking for.